Welcome to the Requs AI Predict software FMEA demonstration. The FMEA function is a separate product in our Requs AI Predict software suite. I'm going to give a quick walkthrough of that right now. Under the FMEA tab, one of the first things we want to do is to identify the hazards of our software system and assess the severity and a likelihood range. You can set the severity range to be anything you want from 1 to 10 or any number in between there. You can define the severities. You can define the likelihoods. And as we go through the FMEA, you're going to identify new hazards, and when you do, you're going to enter new hazards in this list, and later on we're going to see we can easily tag our failure modes from the software directly to these hazards, which eliminates a lot of time and tedious data entry. The next thing we'll do is we're going to define our states. So we can create a simple state matrix here at the very highest level. A lot of people think this requires a detailed design. It does not. Simple system level, software system level state matrix is not difficult to come by. It'll normally be in the requirements or architecture. You can see here we have a state matrix here, a 6x6 state table for a simple digital thermostat. We can see the states here. And X means it's prohibited. A transition, for example, from fault to emergency heat would be prohibited under all cases. And for every other transition here, there's a valid criteria for making that transition. So then we can define our hardware and communication interfaces. One of the common failure modes with software is when the software fails to detect failing hardware or fails to do the correct thing when the hardware does fail. And similarly, when there's a loss of communication, oftentimes the software will fail to detect it or fail to handle when that communication is turned back on. So we'll define all of those. Now we get to the actual FMEA template. And this FMEA template starts with the common defect enumeration, which is published at the DAU RNN Community of Practice website. There's several of them published. Our company compiled this list. And you can see we start with the common defect enumeration. It's got a unique lettering and numbering scheme, which never changes. New common defect enumerations are added, but the existing ones never change. So TLPR1 will always be the same. Its software is unable to perform as required when it remains on for an extended period of time, for example. The next column, the software automatically determines whether this failure mode is applicable for this software or not. And then we can see the root cause, local effect, system effect. Requs AI Predict will make the best attempt to identify the root cause and local effect. That leaves the user to focus on the thing that they understand the best, which is the system effect, the effect on the mission, and effect on the company. Generally speaking, I've done FMEAs for 35 years for software. The hardest part is the first 5 columns. Our software completes those for you to make make it easier for you to do the most important part, which is to identify the effect at the top level. Now you'll see way out here we have the hazard. We can tag each of our CDEs to a specific hazard that we just defined, and it will auto-populate the severity for us, making it very easy. Then on the next tab, you'll see the likelihood. The likelihood tab is where the software is doing most of the work. You can see it here, number crunching. It's going through every single common defect enumeration and computing a likelihood. The likelihood is relative. We do not use failure rates for software. If you want to know why, you can check into one of our videos about that. We use relative likelihood. We can assess it in a relative way using any numeric scale. Like I said, on the hazards and criticality tab, you're going to define in whatever scale your project is using. In this particular case, 5 is the most likely, 1 is the least likely in this example. You can see we have 5 different likelihood considerations. Does it exist? If it does, what will it take for it to be manifested? Are there any controls? Can it be detected? And these likelihoods come directly from the inputs the user enters in on the survey tab, which I'll show you shortly. And then we take an average. It computes the RPN. We do allow you to overwrite those automatic calculations if for some reason you know something that wasn't entered into the software. And of course, then you can justify why you changed our estimations. The mitigation tab provides some suggestions. Under the potential corrective action, we have a suggestion for how to mitigate each of these common defect enumerations. And then it's up to you to summarize how you're going to fix it. The purpose of a software FMEA is to mitigate. It is not to let the FMEA sit on a bookshelf and collect dust. That's not the purpose. If there aren't any action items, then that means the FMEA is not done properly. So we give you some guidance on how each of these can be mitigated. I will go ahead and show you also a few different, you can see different CDEs we have here. The common defect enumerations are related to processing, error handling, state management, data definition, usability, serviceability, algorithms. There's also, let's see if we see it come up here, we have functionality, faulty functionality, timing, machine learning if it's a part of the system. If the system has machine learning, then the machine learning failure modes will be applicable, and so forth. So you can see the different failure modes we have there. And finally, at the very end, when you've completed the FMEA, you can export it to Excel, and you can exclude the rows that the software determined to be not relevant for the application type. You can also exclude rows that have particularly low risk matrix. Now let me tab over to the survey tab here. Under the survey tab, under the product information, that tab is very important. You're going to want to fill this information out. We need to know, the software needs to know what kind of product you have in order to determine what kind of failure modes are applicable. You're also going to want to complete the failure modes tab. These are not difficult to answer. We need to know things like, is the system mobile? What's its power source? What's its operational profile? And others. Let's see what else we have here. We have your controls, the development practices, the design fault tolerance, any design controls, GUI design, and so forth. So it's important to fill out as much as you can from the failure modes tab. Those are the key inputs. You definitely want to fill those out. You should also take a look at the requirements tab, the design tab, the coding tab to some degree, although it's less important than the requirements and design for the FMEA. And you're going to want to look at unit testing and testing tab, because the detectability likelihood is determined directly from your testing methods, and your controls and existence likelihood is going to come from the design and requirements. So you're going to want to fill as many questions of those as you can. We do have an auto import tab, a form that it has only what you need to do the FMEA. It doesn't have, it has the minimal set of questions that can be imported. You can actually fill it out as a spreadsheet. All right, well, that's the end of this. Thank you very much.